Now let's see how we can measure the latent heat of vaporization of water. We're going to collect water in a cup. We dip or we suspend our heater on a retort stand and then dip into the water. We're going to heat this water at its boiling point for some time and check the change in mass. Okay. Now the 100-watt heater is switched on for 300 seconds. The change in mass reading on the balance is 0.20 kilograms. So when we put the water on the balance, we measure the mass. After heating it for some time, after allowing it to boil for 300 seconds, we check the change in mass, how much the mass has reduced to. Then we subtract to get our change in mass. Now, this shows that 0.20 kilograms of water has boiled away. Now remember, power is equal to energy over time. Now if we make energy the subject, we get power times time is equal to energy, as I have stated over here. Now we are going to get rid of energy transferred so that we get power times time is equal to the mass times the latent heat of vaporization. We divide both sides by mass so that our latent heat can stand on its own. So L is equal to P times T over M. Now this is equal to how much power was applied? 100,000. How much time was spent? 300 seconds. So just always remember the time is in seconds. And then what is the mass? 0.2 or 0.02. Now we multiply this, we are going to get 30,000 divided by 0.02. When you do the calculation right, you're supposed to get 1.5 million. 1.5 million joules per kilogram, since we are finding L. So in this experiment, this was the latent heat of vaporization that we got. Now remember, in experiments, there are errors bound to happen if the right precautions are not taken. So over here, we can say that energy was lost to the surroundings. So that means that we required some amount of energy, or the latent heat of vaporization wasn't exactly the amount that we were looking for.